Seth, welcome back to Talk Python. I mean, awesome to have you here.
Thanks for having me, Michael.
Yeah, it's always fun to have you on the show. And you know what? I don't even think we're going to talk that much about security this episode, are we?
Not too much. No, it's
I mean, as I
unsurprisingly
say
like
that, I'm sure we're going to come up with something, right? But the last couple of times I've had you on, it's because you're doing something with security and Python, and it's always been very interesting.
it's true. Yeah, no, I do a lot of security these days, but I do other things too.
Like be the eyes and ears of everyone who could not attend the language summit.
Yeah, so I was the blogger again this year. I got invited back. They didn't. They liked what I did last year, so they're like, well, we'll have this guy again. Why not? Right? Like, yeah, it was great. I mean, I love attending the language summit and blogging for it. It's a really unique way to contribute back to the Python community. It's such a specific role. So
Yeah, it really is. I think maybe we start there. Maybe we start with what is the language summit and why are there not just a bunch of videos online, and why weren't there sessions at necessarily open sessions at PyCon, right? It's a kind of a special event.
yeah, so the language summit historically it is this event that happens every year right before PyCon US. It's been hosted in other PyCons as well, but nowadays it happens at PyCon US, and it occurs kind of at the same time that like tutorials are happening. So that's a day or two before the actual conference starts for like most attendees, where there's talks and all of that. And basically what ends up happening is a bunch of core developers and triagers and some special guests all convene into one room for a full day of like short talks followed by tons of discussion. And the reason that it's like a closed session is like, one, it's a logistical thing. Like the room is only so big, and I'm pretty sure the organizers know that if it was just like open session, it would be like, oh, we need to have this huge conference room of people, and it's not really conducive to discussion because it is very like fast moving, asking questions, getting answers, and having people be able to exchange this information really quickly. And so to offset the lack of openness, right, because not everyone can possibly attend that wants to attend, what ends up happening is a blogger, someone who covers the actual event, every single talk, every single discussion, all the questions, what gets discussed, and then like the vibes of the room and like how people are feeling about topics. That gets covered by a blogger, which this year was me, last year was also me, but then the years prior has been like Alex Waygood covered the year prior to me starting. So Alex taught me everything I need to know and what to expect and all of that.
Nice. Yeah. And I had you on last year, and I had Alex on the year before, I believe. So it's a bit of a tradition.
There we go.
Cool. And yeah, also people should know it's a working session with the goal of not just presenting ideas, but making decisions, trying to come to an agreement with the core devs and steering council and maybe other councils, as we'll see, all the councils.
Yeah, right. No, it's lots of decision makers in there. I feel like it tends to be a really great arena to kind of just get really quick feedback on either ideas or questions. Because like even it's really funny. One of the talks happened. Not to get into too much detail right away, but like one of the talks happened. They're like, "Oh, we have this problem. We really need more ARM builders for GitHub CI for this specific reason." And E. Durbin, director of infrastructure at the PSF, was in the room, and they were just like, "Oh, I just bought more," and it's like, "Oh, great,
Oh, that's awesome."
quick feedback."
That's the way to make it happen. That's right. You know, before we get into that, just maybe it's worth a quick conversation about. You were actually in New York City. We just heard a siren go by, so we now officially know that you're in New York City, right?
Yes,
There's
exactly.
always something going on there in terms of noise or energy or whatever. For the UN open source conference, that sounds
Yeah,
super interesting. What is that?
yeah. So United Nations Open Source Week. I got invited to attend through the Sovereign Tech Agency and also Alpha Omega. They are collaborating to host a maintain-a-thon, which is essentially just get a whole bunch of open source project maintainers, project leaders, governance people, like people doing more than just security. So I was there to represent like the security perspective, and also Python Software Foundation. And just getting us all together and trying to talk about really complicated issues for open source and how open source can be used to better the world, to be a part of, a more open access world, more open data world. Those are kind of like the themes. And
Interesting.
specifically the Maintainathon was more like hosting small sessions with lots of discussion, almost kind of like the Language Summit, where there's a really short presentation about a topic. I presented on low energy security, so security practices and processes for projects that don't have access to tons of security expertise. And then like, what are how can we make the situation better for those types of projects?
Oh, very cool. There's a lot of energy for open source in the United States corporately, but internationally, there's a lot of energy for open source at a governmental level. More so, way more so than the US. I mean, there's little pockets of things like, hey, we'd like to have some open source initiatives for what we're building in the US, but I can't remember what country's doing it right now. One of the countries is trying to replace basically Microsoft Office and Windows with something Linux and open source, and there's a lot of stuff like that.
Yeah, it's about having sovereignty over your technology stack, right? Making sure that you have complete control and that there's interoperability, and that being able to work independently as like a government agency just as important as a company, right? You want to make sure that you're able to control all of the processes and data that are inside that are important to you.
Sure. And I think we're in a bit of a special situation being in the US. I don't think we have as much of a feeling of, wouldn't it be nice if we weren't beholden to US companies? Because we're already beholden to the US. We live here, we pay taxes, we're subject to the rules. But if you're outside of the US, most countries and organizations are still beholden to U.S. companies, and I think that that's a part of the a vein of the ideas there, right?
Yeah, it definitely is a part of it. Being able to do your own thing without worrying about other countries, what they're doing or what their relationship is with you, and still being able to interoperate on a global scale, right? Because like a lot of these formats are open and they interoperate, like PDF, DocX. They're all open. They can be written by any software, not just Microsoft software. So
yeah, absolutely. And I guess that's true for the US in terms of software, but not so much for hardware, right? We're more in the same boat as everyone else with hardware, but that is a bit too far down the weeds, maybe, too. We don't need to debate that, but it's super interesting that you're at that conference, and it sounds really fun.
Yeah, it's a great time. A lot of really smart people here, so I'm happy that they let me in.
How'd I get here?
Exactly.
What office did you run for to get elected to that?
No, none of them.
Cool. So let's talk Language Summit. When we started, like sort of backstage, we were trying to plan out some of the themes and stuff. You talked about there being a couple of major themes of the Language Summit this year. And I certainly, reading your write-up, thought like, wow, multi-threading has got some attention.
Yeah, free threading was a big part of the Language Summit. I think it was like somewhere between a third and a half of the talks touched free threading or parallelism or the concurrency model of Python. It was obviously a big theme.
Yeah, what are some of the other themes?
Yeah, so the other ones are things like, okay, we have all these other platforms for Python. If you read like the last year's Language Summit, there's kind of this through line of like mobile and web both kind of got discussed. And so if you contrast like the status of those projects then, what the write-ups were to now, the projects are way further down the line. So like Russell came up and got to say like, oh, mobile for Python, both on Android and iOS, are basically here. And huge round of applause from all the core devs because they were super successful in achieving the mission that they set out to do back a year ago at the Language Summit, where they laid out what their plans were. So yeah, it will be basically mobile support. I think it's for 3.14, I think is the hope that it's going to be actually like working and you should use it and you can build apps with it. And
Yeah,
That's really
awesome.
exciting.
It is very exciting.
Yeah, and then the other platform is web, obviously. So Pyodide is one of the big ones there. So if you've heard of like PyScript or Jupyter Light uses Pyodide, both of those platforms, like for Python on the web, there was this talk about upstreaming the FFI, the JavaScript FFI, and some JavaScript APIs to CPython, as opposed to keeping them resident in Pyodide. And what that would essentially mean is that if you ran Python compiled for what was it, like the WebAssembly platform, you would be able to interact with JavaScript from like the standard library, like the OS module or something like that. And
Right,
that
right.
is pretty exciting to hear something like that. And there was also some talk about like apparently recently MicroPython got web support, and so like trying to unify a little bit the APIs that the two are using.
Yeah, that's super exciting. We'll definitely dive into it, but the fact that MicroPython got web support means it's possibly a good use for broader web applications, right? Because Pyodide is awesome, but it's also something like 10 megs or it's somewhere in megs, and it takes a bit to load up because it is basically CPython.
Yeah.
Whereas MicroPython's 100K, and people are used to doing 100K JavaScript, but not multi-meg JavaScripts for standard stuff. So yeah, really exciting. We'll dive into that. So, not surprisingly, I thought we could just maybe work our way through the different presentations. How long is each presentation besides the lightning talks about?
Yeah, so it's each session is, I think it's like 30 minutes. The talk itself is usually like 10 minutes. I could actually bring up the schedule. I should know this off the top of my head. The presentations are super fast. They're like 10 minutes, and then the rest is discussion. So
Yeah,
it's
sure.
quite a quick format.
And your write-up mirrors that, right? So if people read your post, I'll link to, what I'm going to do is I'm going to link to the meta post, I guess, in the sense of like a meta package, in that it says, here's all the articles for that I wrote up for the Language Summit, so you can jump to the ones you want to see. And your write-ups mirror that. It's like, here's what happened in the presentation, and then the discussion that happened below it from all the core devs.
Yeah, it's short presentation, and then it's just like immediately into questions, feedback, all of that. So it mirrors it.
Yeah, cool. So the first one, I didn't always write down the names here, the first one is, how can we make breaking changes less painful, by Itmar Oren. And so this one, Itmar deploys a bunch of Python code for production at Meta, and said, going from version, 3.11 to 3.12 or 3.12 to 3.13 has breaking changes that can be challenging. I don't encounter too many breaking changes in upgrading Python versions, but I also don't have literally millions of lines of code doing intricate things either. So, right, this is a pretty edge case, but also an important one, right?
Yeah. This talk, I think one of the big things about this talk too is it wasn't just about like, jumping from one version to one version. A lot of companies employ like a skip version upgrading style where they'll experience breaking changes in a slightly different way than a lot of other users, where they're jumping from like 3.11 to 3.13 as opposed to like 3.11 to 3.12 to 3.13, because upgrading is obviously this like big task, and so they don't want to do it every year. Maybe they do want to do it every 2 years, and that's fine for them unless there's some feature that they really need or something like that. But yeah, so like anytime that you're upgrading more than one Python version, like the breaking changes are obviously twice as many on average.
Yeah. Sometimes they even go from 2.7 to 3.11.
Yes, and on rare occasions they go from 2.7 to 3.11. Yeah. Thankfully that happens less and less.
Yeah, that's a story from the last decade, thankfully.
Yeah, so this was like
talking
talking about like, okay, how we're not trying to say breaking changes shouldn't happen, because we know that they're important and they're a good way to unblock things and remove pieces of software that we don't want users using. But trying to make it so that we can almost like quantify how bad a breaking change will be for users, and then based on that quantization, figure out what we need to do, maybe extra, if it's like a particularly bad breaking change, or if it's just like, oh, well, this has been deprecated for 5 years, and then removing it, or like there's an easy drop-in replacement that's one-to-one. Like those sorts of breaking changes are really easy versus things like, oh, this behavior changed and you won't know until runtime, and things like that are way more difficult. You have to have like a test harness that's actually testing all of the possibilities in the code to know whether you're safe or not, versus like a syntactical control F, find the bad function and then replace it.
Yeah. And it could be super subtle, right? It could be the runtime things, but it could also be the memory structure of something we put into a Redis cache via pickling has changed. Yeah. And the cache version no longer works, and we have to somehow figure out how to completely delete the cache and start over. And some web apps, that's a problem, right?
Yeah.
When they're under tons of traffic, that sort of cold start experience can be a problem.
Yeah, and there's even things that like aren't even part of. This gets mentioned in a future talk about parallelism, where it's not even a function of the language, but it just happens to be a property of how a particular set of code executes in one version versus another. So like with from the difference between 3.9 and 3.10, where something is thread safe, that it doesn't look thread safe at all. Like if you look at the code, you're like, oh, that's not thread safe. But the GIL, like the implementation of the GIL in 3.9 keeps it thread safe, but in 3.10 and beyond, it's no longer thread safe. But the thing is you were relying on behavior that's not defined in
It
Python.
wasn't guaranteed. Yeah, there's no guarantee that.
And so it's like, is that a breaking change? No, but also like it'll probably break somebody, and also how do you detect that at a syntax level? You can't. The syntax is the same.
Should it be written down as a breaking change? I don't know. Maybe. Does your code feel broken if it gives you different answers and those answers start becoming wrong? Maybe.
Yeah, it's tough. Maybe. It's a really tough thing. I think core developers were like pretty happy with the idea of like treating different breaking changes differently, trying to develop some sort of taxonomy of breaking changes. And there were some interesting ideas with like running these like code update scripts, providing code update scripts that if you have code and there's breaking changes that are on the syntax level, being able to upgrade them. Apparently Rough had some ability to do this for two major versions of NumPy. And so like that got brought up as an example of like, oh, this worked really well for NumPy, so maybe Python.
Yeah, absolutely. Well, absolutely. I think Rough is certainly in a good position to do that. Yeah. You could say this pattern isn't wrong, but maybe it should come up with a warning just so you know. Run this check if you really want to see, right?
Yeah.
Yeah, so one of the things Idmar pointed out was it's difficult to find the documentation of deprecated and removed modules because after a module is removed, the documentation is also removed. It's a bit of a catch-22. Yeah,
that one was really interesting because like especially if you're skipping versions too, like you go to the docs and the module's just gone, and you're kind of left to figure out what was the last version that had that module, when did the deprecation warning start, where's the warning, like where's the actual documentation that says what to do. And so apparently the docs editorial team are working on that. They're trying to figure out a solution for better documentation for removed modules specifically, or removed modules.
Yeah, Carol Willian said they were working on that. Very interesting. You can go to the documentation like docs.python.org and pick through it, but by default it lands on the latest, right?
Yep, by default it lands on the latest. And if there are any like links to modules or to deprecation warnings that aren't like pinning to a specific version, it'll go to the latest and it'll be like, oh, we don't have those docs anymore.
Yeah, it's just 404. You're like, huh, weird.
Yep.
Weird. Okay, well, very, very interesting. The next one we have an uncontentious talk about contention. And now we start into the heart of the topics, which is threading, async IO, parallelism, concurrency, all of these things, right? And this is the one you were referencing when you ask, is this code thread safe? So just give people a sense. There's an incredibly simple parallel example of create a counter class. The counter has a value. You can run some code that goes for 100,000 times, increment the value, start 10 threads that all jam on that. And then this is by Mark Shannon. He says, we would like this to print exactly 1 million. I'm not sure that that's necessarily true. You would, as a creator of this program, you want it to exactly print 1 million, but there might be advantages to allowing code to run more parallel rather than less parallel, and say it's on the author of that code to make it thread safe.
Yeah.
Well, right. Yeah. It might, if it's 5 times faster because Python the runtime doesn't make it thread safe. Maybe you choose the time and the way that you run that code. That's all I'm getting at. Like, we would like it to print exactly 1 million times as a correctness, but maybe it's not Python's job. But
no, I think maybe that comment is like not necessarily like we core developers should want this program to print exactly 1 million. I think it's more of like, oh, if you were someone who's writing this code, you would maybe expect it to print 1 million because you're like, oh, in 3.9 and before it prints 1 million, so like that's fine. But then
so you know what changed in the GIL?
I actually don't know specifically what changed in the GIL. It was something to do with context switching in the GIL made this no longer change. My guess is that it's performance, like you said. There's some
exactly. They probably said we can make the GIL more fine grained and get more perceived cooperative or preemptive multi-threading as it goes, something like that, right?
Exactly.
Yeah, and that's kind of what I was hinting at there. Okay, so that's the that's the story. And basically Mark said thread safety is a property of the program, the Python code you write or someone's written, and the implementation of CPython and how it behaves. In this case, the GIL, right?
Yeah. So I think the big thing for Mark's talk was the synchronization quadrant, where he is basically trying to like make some bets about like what's going to happen next to try to solve some of the problems that we're going to start seeing for parallel Python, right? And that's either anytime that you have both mutability and shared references, you have problems with synchronization. And if you introduce more immutability or less sharing, then you're starting to solve these problems. But the unfortunate thing is that there's a lot of Python that happens in the shared and mutable section. And we don't want to have to like ask everyone to rewrite all their Python programs. So it's definitely like a tough like quantization problem, like how big of an issue would making changes like this be? But then also like we don't even really today give people a ton of the tools that they would need to be able to work with like immutable data structures, because like we have frozen set and we have tuples,
frozen tuple,
frozen list, frozen dictionary, any of that. And so Mark just basically gave a whole bunch of things where it's like, here's all of these ideas that I have for making this more easy, having more immutability, and we should probably start thinking about that now because we're starting to get into free threading time. So.
Yeah, certainly. A threading collections sort of deal would be great.
Yeah, I think the final thing there was like, oh, we should definitely be doing this on PyPI. And I think the free threading team is planning on creating some immutable data structures and putting them on PyPI at first before migrating.
Oh yeah, that's an interesting idea. Like take them for a test run before they get baked into a pattern, right?
Exactly.
You know, one of the things that I think is a danger of those types of data structures, and they, don't get me wrong, they're useful and they're good, but one of the dangers is they can give people a false sense of security, right? If you have 4 or 5 lines of code that is changing state, check to see something that is in the list, and then in the next line, remove something from the list, even if that list itself is thread safe. If it's immutable, that's one thing. But if it's a mutable list that you're trying to make a thread safe version of, it's still possible that the check was thread safe and the remove was thread safe, but something happened between those two where the thing's no longer in the list, right? It gives people this sense of, well, I've got a thread safe collection, so I'm good to go. It's like on a line by line basis, that's true, but as a block of code, it's still not true. And you still have to think more about these things. That doesn't mean you shouldn't have them, but it is like an awareness sort of thing. Cause like, I'm doing thread safe. Look, from system.threading.collections import, whatever, we're good to go. Like better.
Yep. You actually have to use the data structures. You have to use the immutable ones. Don't use the mutable ones and expect thread safe.
Yeah. So but it is certainly in the right way. There's some pretty extreme in terms of how much they would change programming paradigms and ideas, suggestions here. And I don't remember how these are starting to blend together, these different topics, but yeah, like one of the challenges is that functions and types are mutable. Mm-hmm. Right, and that makes it hard, even at a CPython implementation runtime level, of dealing with some of these things. But changing them breaks the sort of the style of Python somewhat.
Yeah,
that's a trade-off, right?
It's a huge trade-off. Yeah, and the fact that everything is mutable and a lot of things are shared, like the standard library, the whole standard library is shared across everything. It's really difficult to say that, oh yeah, if you're in that top right quadrant of shared and mutable, which way does like the standard library move? Like you can't make everything immutable and you can't make everything not shared. So it's, what do you do?
Yeah, for sure. And it's also a performance issue that you could, because, like right here, Mark points out that where mutability is allowed today, maybe it is there, but not for a good reason, like functions and class method resolution order, all that stuff. It's mutable, but should it be? The thing is, if it's going to remain mutable, you probably have to do locks and stuff down in CPython, which will slow it down. If it were immutable, you don't have to lock it. Like you can read from multiple threads all day long and it's not going to hurt anything. So it's actually a performance consideration, not just a flexibility, right? If you say like, we really value this multi-threading and we want it to operate as quick as regular Python, but scale really well. These are trade-offs you got to consider, but then we all have like scars from 2 to 3 and this could be a little like that.
Yeah. I think it's going to matter. And I think that like companies are going to have to maybe start even like profiling their own code and trying to see where they're hitting those stop the world locks or any sort of like performance issue, like, and trying to like track down where in their code we're hitting those like really expensive operations. And if they're trying to write this like extremely high parallel code, having a way to profile it sounds really like a good idea, because I think that there's like going to be, once this starts happening, people are going to have to start thinking about like CPython, the runtime. What are the expensive operations that are happening in my own code that maybe could be done differently to take advantage of free threading completely?
Yeah. Well, and going back to the opening part with like the red safe collections and so on, it's really difficult for us as Python devs to create those, because we could write that in Python, but that makes it fairly slow. You need that down at the machine level, right? Like probably CPython. We'll see if it's CPython or RPython or whatever as we go through this series of talks. But at the time of recording, it's CPython, right? It'd be way faster if there was in the standard library C implementation of a thread safe thing that's not being coordinated by a bunch of calls from the Python level.
Definitely.
Okay. I guess closing this one out, Mark suggested adding a freezing methods to data structures like byte arrays. That's kind of what we were talking about. And Barry Warsaw said that he brought up a proposal, a PEP, that was a freeze protocol that was rejected 20 years ago. Those were different times. Right? How many cores did we have? Or was it like a dual, a Pentium?
Single digit still.
A dual, yeah, certainly a single dual, maybe a quad core if you were awesome back then.
Yeah.
That's not the case anymore. So the benefit of having something like this is certainly higher. So
yeah,
I was like,
and
why was that rejected again? We don't know.
Yeah, freezing comes up yet again in another one of the talks about fearless concurrency as well. So I think that something like that is probably going to get resurrected, at least tried to be done again.
Yeah.
I don't know if you wanted to jump to that one, because I think that one in the uncontentious talk is quite pretty
You're talking fearless concurrency?
Yes.
Yeah, let's talk that one. So that's by Matthew Parkinson, Tobias Rigstad, and Friedhof Stoltz. Yeah. Hopefully I did justice to your name, folks. Yeah, so fearless concurrency. This was one of the more detailed ones. And so this one, I don't know how I feel about this one, Seth. This is one of those things where it's like, if we take this really wild idea that really changes the way people have traditionally done programming for concurrency, then we could get great benefits. But it also is like I don't know what your assessment is. My sense is that most Python people don't think a lot about threading, haven't done much threading, and are not their skills of threading, problem solving, using fairly straightforward things like locks is still pretty much like, I think they have those in the language. You know what I mean? Like, not really like, I use event signals and all sorts of like producer consumer, like not very much of that. You know what I mean? Mm-hmm. And so anyway, tell us what this is about, because it's an interesting concept.
So
debate it.
This concept is all about, so like the central concept is regions, and regions are essentially, in Rust, they have this model where a mutable reference is only allowed to be, like, a mutable object is only allowed to be referenced once, right? Like, that's the ownership model in Rust. But that's like not compatible with how Python programs are in general. Because we love our mutability. And so this is essentially like, okay, well, what if we could have kind of like a looser version of that, where you have objects that are doing mutability and all of that within a region, but then anything outside the region can't mess with it. And then if you have that situation, which is more common and more like understandable for like a Python programmer, then you can get a bunch of performance benefits, because you know that nothing outside of the region is going to be doing any sort of like that special mutability just out of nowhere. We're going to change something about your function signature or something. And so then when you have this situation, you can even do, so this diagram is showing all these references into that region from a specific thread. We know, because of how the region is created, that the other thread can't modify anything inside. And so you get a bunch of performance benefits for all of the operations that are happening inside that region. So I think that's kind of like the elevator talk. Regions are like Rust, but better for Python programmers.
Yeah, sure. And if you want some other thread to have access to it, you've got to make all the things in that region let go of it so that it can be transferred ownership over to the other thread, and so on. And it's an interesting idea. It like I said, I feel like it's powerful, but I feel like it might be a bridge too far. I don't know.
I think that again, immutability came up here. They even had some talking about like being able to freeze regions, and so like you create a region of objects and then freeze the entire region of objects, and then none of those references can get modified. And so the whole freeze protocol discussion kicked off again. So maybe something to look forward to, freeze protocol in Python. The region-based ownership it was definitely an interesting. I feel like, yeah, like you said, there's a bunch of people that were asking questions about like how much is the benefit.
Yeah.
And it's this different, like to take advantage of it, you would have to change your code slightly, so it's not just this like free thing that happens. It's more of like okay, if you're like a library or a project that really wants to take advantage of tons of parallelism, you would use these features. It wouldn't be just like, oh, every Python programmer, once they upgrade, they just get a bunch of free performance. So.
No, of course not. Of course not. Yeah, I feel like there was some interesting questions, like it's an interesting discussion, but for some reason I left it out of my notes here. But
Let me see.
there was, so one of the things is there's basically 4 PEPs proposed, or at least imagined. I don't know if they're actually proposed yet.
No.
That would make this happen, but maybe it's coming from a different section, but a different freezing conversation somewhere else. But there was the conversation like, okay, well, I've got a list. The list has a bunch of pointers. Some other thread got a hold of one of the items that's somewhere in the list, but I freeze the list. And so the list is frozen, but then you still have this object graph that has like leaked some of the mutable data, right? So you could use that one pointer to one part in the array, and you could be making changes to it. So there's like this discussion of object graphs as their whole becoming invalid, or like they're becoming problems with like trying to share those that were not obvious, right? Like really subtle programming challenges. Not a race condition, but kind of a syntactical structure behavior problem that you run into when you can say, well, this section is frozen, but someone got a piece of it. So now what do you say about it? You know what I mean?
Yeah, I think the idea with like freezing and regions and all of that is it would definitely be tracking the number of references that are held by objects that are outside of the region. And so like if you would then try to like freeze an object or freeze that region, it would know that it's being referenced by something outside of a region, and it would raise an exception instead of like allowing that to happen. Because like right now it would just allow it to happen.
Yeah.
Whereas like getting an exception that, hey, a race condition is possible in this situation, we're not going to let you freeze this object or freeze this region like that. I think that's like a better user experience, because if you're using regions, you probably want these properties.
Yeah.
So
And that is a big benefit of that proposed idea, that what would have been a runtime either race condition or deadlock becomes an exception that tells you this would have been a problem, which that's massive.
Yep.
Yeah. So, okay. Interesting. My first impression is that it's too much. It's too much for the Python people.
Yeah,
I'm sort of counting myself. I'm not like just throwing shade. Like I'm sort of counting myself in the same group to some degree, even though I've done a lot of like lock event based style threading still, you know.
No, it is interesting. I think that it is a really good idea for them to break their project down into multiple PEPs instead of trying to like, land this huge jet plane at the very end of the project. Instead, just like try to incrementally, because I think that it'll be interesting going into the future, seeing how many of these PEPs land, right? Like, will it be all of them, or will it be one of them? I think there are some interesting things in this project, even if we don't get the entire region-based ownership model. So.
Yeah. Okay, interesting. Jumping back one in time, we've got number 3 of 9, so I'm feeling like we're going to have to go faster.
Yes, we might have to.
This one is really interesting. This was a long conversation, at least a long write-up. This is the state of free-threaded Python. And the question is, does it make sense to move to the next phase of PEP 703, which is, I believe that's the one that defined free-threaded Python by Sam. So this presentation was done by Matt Page, saying free-threaded Python has come quite far. And I believe since actually this was done, this PEP has actually moved forward to say, yes, we are moving on, right? So this is a bit of the lag that you were talking about.
Yes. So I just, I shared a link with you also. this just came through from the steering council. How long ago? A day ago from this recording.
Oh, yes.
Dating the
We bring
recording
you
a
the
little
fresh
bit.
news, folks.
Yes, where PEP 779 basically removed the experimental tag from the free threaded build. And yeah, I think that this presentation probably had a good chunk to do with that, where they showed off, here's the state of everything, here's our proof that the community is adopting it at the expected rate at this point in the project, especially like the scientific computing community, where like the benefits of free threading are huge. We're seeing all this uptake. We're seeing within the bounds of the performance allowance for single-threaded performance. Can we remove the experimental so that we can see this like next wave of adoption? That was basically the whole point of Mats, and it seems like the answer is yes.
It does seem like it's yes. Yeah, that's very cool.
Yeah.
It means yes for 314. So what was it, June? That means yes in like 4 or 5 months.
Yep. Stay tuned in October where you get your stable, but please test your betas.
Which, yeah, we're already into beta, aren't we?
Yep, we're already in the beta phase, so test your betas, folks.
So I guess it's worth pointing out just a little bit for folks who haven't been tracking this super closely, like you and I. This free-threaded Python's PEP 703 deal, I haven't seen anything like it, but I haven't. There might have been other stuff like this, and I just didn't notice. But I'm all about the threading, so I've been paying more careful attention in that it was accepted, but conditionally marked as experimental, and with the caveat that we may take it away from Python later if we don't like it anymore.
Yeah.
Which is an odd acceptance, I thought.
Yeah, that mechanism of, I think it was just this knowledge that this project would last multiple steering councils. And multiple years, and we were kind of going into the brave unknown a little bit, and acknowledging that hey, if it doesn't work out, we're gonna have to pull it all out, and that is unfortunate, but it's just reality. We don't know what we're gonna experience, but we're gonna find.
Yeah, it's such a big change, and so one of those criteria was it can't slow non-threaded Python down too much, right? And it looks like that's within 10%, unless you're on a Mac, then it doesn't seem to matter for some reason.
Apple Silicon.
Yeah, Apple Silicon is magic. But also with memory, right? I think it adds a little bit of a memory overhead for extra data structures to track like safe reference counting and stuff.
Yeah, and actually the new acceptance criteria for the next stage actually explicitly mentions the memory allowance. This is like in Donghee's new post about it, is that there's actually like an explicit number now. I don't think there was before. I think it was just tracking the CPU performance.
Yeah, interesting. And I guess it's worth pointing out, there's a couple of resources that you highlighted here. There's a resource page by QuantSite, which is a big data science crew, that talks about what are the different projects that are relevant, I imagine, to the data science folks, and what is their status with supporting being tested, being released for free threading, right?
Yeah. No, these sorts of statuses, and there's also one from Hugo, which like tracks which wheels have the free threading available for just like an easy pip install. And in theory, that kind of means that these projects have tested it with free threading.
Yeah, it looks like we're at 20%, I guess.
Yeah, we're doing pretty good for this stage of like, it's experimental and it might get ripped away. Like that was what it was before. So
exactly.
People are trying it out. I mean, like this is how you get proof of people willing to try it. I know that inside of the actual Language Summit discussion, they also talked about like wanting to dig in deeper into this data, where it's like, okay, the projects support it, but how many users are installing those wheels to kind of show like how much is the community testing out free threading? Because just because a project supports it doesn't mean that like the community is trying it out at the same level, right? So maybe that'll be relevant for the future.
I suppose at least for the ones that offer true free threaded wheels, you could use PyPI data.
Yep, the Limehaul, Google Cloud, BigQuery, or BigQuery.
The BigQuery thing. There are other ones that are, well, it's just pure Python, so it probably works. That's harder to quantify.
Exactly.
So yeah, the basically that change came along here. It says we support moving to what do they call it, phase 2, something like that. So there's multiple phases still, but yeah, excellent. We talked about this fearless one. We're no longer afraid of it. People are tired of hearing about threading for a minute. How about governance?
Yeah.
Yeah. So Eric Snow did a presentation entitled "The Challenges of the Steering Council." That's pretty interesting here. Tell us about this one.
Yeah, so this one was kind of talking about, as a core developer, how is the experience of having a steering council governing the development of Python? How is that working out right now? What are the challenges? What's the good? What's the bad? And I think the highlights are having a completely rotating governance set of people on a council. Even if that means that like most people are still on the council year over year, you still have that like whole complete stoppage of time because people are starting to kind of like wind down because they know an election is coming. And then,
right.
So like PEP development gets impacted by that, right? If you're not timing your PEP authorship right, then sometimes you just get these huge delays. Also talking about like how much the need for consensus impacts people's ability to participate in the discussions. So before, you could just participate openly. You don't have to worry about like, oh, am I speaking as the steering council or am I speaking as individual or core developer? But now there's like such a need for consensus that it kind of puts steering council members in a weird spot where they can't participate in the discussion unless they've already talked with other people in the steering council or do that as easily. And I think there was one more.
Yeah, one of the threads was, I had a conversation with somebody who is a core developer, but also happens to be on the steering council. I felt like we were in agreement on this idea, but then when I spoke to them as steering council member, then the story changed a little bit because it was a committee response. And you're like, I think Eric Snow himself expressed frustration that like, I've worked on this project. I thought we had agreement, and then turns out for some reason it wasn't, right?
Yeah, I think it's really hard to know if you have consensus when the like response right is delayed, because you can't tell then if it's consensus because like the discussion is slowed down and no one's bringing up any new points, or if it's because like people have thoughts but then they have to talk to their steering council fellow members, and then it's difficult to judge, and you don't really want to tip the hat one way or the other during the discussion because you don't want to get people with false hope. You don't want to like tell people not to work on something when it's actually going to go through. So it's challenging.
Yeah. Two other issues. I guess it's also worth pointing out before I say this, that Eric said, look, things are working pretty well. Python hasn't stagnating. PEPs are getting approved. Things are happening, right? So that's good. But one challenge is just it's slower to get responses about PEPs and so on because it's volunteer committee work rather than one person who can just be the decider,
Mm-hmm. Yeah, it is really tough, and especially, and this kind of comes through with like, here's all these things that are happening to Python all at once, and good luck steering council with like trying to make all of those things work together, because the thing is the steering council wants all of these good projects that are happening to Python to all land and to all have a good time, but they all interdepend on each other. I know that there was people were talking about delegation as like a potential solution for this. And I think the steering council like loves delegation. They want to delegate more, but they sometimes have an issue with delegation when it comes to these topics that like overlap with other big projects that are happening concurrently in Python, where you can't delegate someone for free threading because free threading touches everything. And so if you delegate something for free threading, then that person is not looking at all the other projects that are happening in Python, and that's a problem.
Yeah. I think two other things I want to touch on real quick. There's a lot of interesting stuff in this one.
Mm-hmm.
One is visibility into what's happening in these steering council discussions, right? And it's a little bit addressing the surprise, but also just knowing, kind of like you did for the language summit, you brought a lot of visibility and awareness of what's happening there. A lot of this wouldn't be known, especially what happened in the discussion, if it weren't for something like that. So Guido pointed out that California, where he lives, has the Brown Act, which requires all meetings, like governmental meetings, to be open to the public for local governmental groups in charge of infrastructure without private deliberations, barring personnel issues or something like that, right? So basically, there's regulations or rules for saying, like, here's how this stuff is open. Maybe all the conversations are all the meetings are live streamed, or who knows, something like that.
Yeah. No, there was a lot of different options thrown out there for like how to make these meetings or the deliberations or decision making of the steering council more open. One of them, Guido put out there that like, oh, maybe they should just be open. Like everyone can see it like a live stream, or like the meeting minutes are just, transcribed instantly and then published the next day or whatever, like something like that. Or because right now they publish meeting minutes and they're getting more regularly doing that, like actually getting the meeting minutes out on time. I know there was like there was definitely some issue with that in the past where like the meeting minutes were really delayed. And so it's really hard to keep up to date with what actually got discussed.
You want the 2025 version, not the live stream, but you put your AI assistant in all the meetings.
Sure.
And let it create meeting notes. Honestly, it probably wouldn't be that bad. It would, there might be a few things like, oh, yeah, you got that wrong. Sorry. But in general, I think it'd be pretty good. And then the last thing here is there was some conversation of like, well, deciding by committee is tough, and how much of the community should we listen to? And somewhere it was proposed that maybe things like discuss.python.org, we've had polls and people said what they wanted and didn't want, right? And Barry wisely points out like polls are useful, but there's a whole bunch of people, millions of users that are not participating in discourse. And I just want to take the moment to like restate. I think that Scott Hanselman has such an amazing topic or idea here where he talks about the dark matter developers, the unseen 99%. I'll link to this. So obviously we know what dark matter is in astronomy, but like these are people who just go to their jobs. They don't spend their evenings on discussion boards. They don't go to conferences and participate in panel discussions. They're not on social media. They just use Python or whatever language, and they do their thing, and it matters deeply to them, but you won't ever notice them in these polls or PSF surveys or whatever, because they just don't do those things. There's probably a good chunk of them.
Yeah, and the steering council has the difficult job of representing these folks too, because they're trying to do what's best for Python, and that's for everybody, not just people that vote in polls on this.
Right. That's what Barry was saying. It's tricky though. It's like, how do you measure that? You know what I mean?
Yeah, it is super tricky.
All right. Packaging.
Yeah, so this one was really quite a quick talk where it was mostly just talking about, hey, this PEP is happening, the packaging governance process. I know that this got discussed a lot more in the packaging summit. Here, I think it was mostly just like, hey, this is happening. Here's what the steering council needs to know. Here's what core developers need to know. This whole thing came out of the Wheel Next directive, which is like wheelnext.dev. They've got their own website. And it's basically trying to adopt the steering council model, but for packaging, because right now packaging PEPs tend to be delegated to like one or two people. And obviously if things 10x or 100x in complexity and concurrent projects, it is just not possible for one person to just be doing that work. And so trying to adopt a council model similar to the steering council. And I think the biggest like open questions right now are things like, how is that initial council and like how is the voting body going to be formed, right? Because like the voting body for the steering council is core developers, but what is the voting body for Python packaging, right?
Right, exactly. And again, it runs into some of the issues of sort of delegating, but packaging touches everything and so on. Yeah. Tricky. Okay, excellent. And you referenced this one, Python on Mobile, by
Yes.
Russell, Keith McGee, and Malcolm Smith. I just had Russell on the show not too long ago to talk about some of this work as well. But he says, after many years, this year I can say that Python on Mobile is there, met with a large round of applause from the room.
Yep. Yeah, it was an awesome moment, especially because I covered kind of like one of the last status reports before the big hurrah. We did it with Russell and Malcolm. Yeah, basically both of the PEPs for Android support and iOS support are finished, and they are tracking really, really close to basically adding tier 2 support for iOS and Android to Python. And tier 2 support basically means that if any feature change or bug fix or anything ends up breaking support for that platform, then a release can't proceed. So the platform basically needs to be supported for a release to happen. And that's a huge deal because it means that people can be confident that support isn't going to just be taken away or not surprised it doesn't work, which is great. So basically it just means there's hopefully a whole new set of users that can use Python to build on these mobile platforms.
Yeah, that'd be great. So specifically PEP 730 and 738, meaning that CPython builds and runs on iOS and builds and runs on Android, right? And that the core development team considers, breaking that build part of breaking Python, right? There's still work to be done in terms of tooling, right? Yep. Like I'm not going to get a Python plugin for Xcode and drag a storyboard across and then publish it, right? Some of that stuff is coming from the Beware team, backed by Anaconda, which is great. But I think this announcement is like the runtime CPython bits are in place, right?
Yeah, definitely. So it's not like, oh, suddenly Xcode just works and you can just write an Xcode project in Python just as easily as you would write, a web app in Python. But yeah, the fact that it works at all, like the fact that you can run it on an iPhone or on an Android phone, like that's huge. And the core developer team is willing to say, yeah, this is going to keep working. So
they should. It's not a flash in the pan, these mobile phones. Some people use them.
Allegedly.
Allegedly. How many do I have around me?
I know. As I have one in view.
Yeah, exactly. Where's the iPads and all the other stuff? Yeah, if I never see Xcode again in my life, that would be too soon. It's just such a bad piece of stuff. It's such a bad tool for building software. I've had to work with a lot for our mobile apps.
I've thankfully not had to dealt with any app development yet in my career. It's been all web development.
No, it's such you don't appreciate the freedom that you have. I know open source means freedom in some ways, but just the ability to go, I made a change, I published it, the world has it. It's not like I've had a debate with random people who are in a hurry and don't care about what I've built, and then they tell me that it infringes on something somebody else built, even when that's actually not true because they don't understand what it does. Like, that's even outside a
lot more people involved in mobile publishing,
and rules that don't align with your incentives. Like, we want to extract money from you. Anyway, that's a long story through in-app purchases, and okay. Another one, I hinted at this, like, are we going to need to change the name of CPython? Because CPython means literally the C language implementation of Python. What do core developers want from Rust? And do they want Rust in their CPython? Is this a Reese's Pieces, Reese's Peanut Butter Cup sort of thing? You got your Rust in my C or something,
R&P,
right?
Reese's yeah. This was a really interesting one because I think that the room was maybe a little bit surprised by how open core developers were about maybe the idea of something optional being in CPython that is written in Rust. Because CPython, there's the core runtime, right? There's the syntax, there's the interpreter, there's all that stuff that everyone uses on every single Python session. But then there's also all these standard library modules, OS and sys and SSL and all of these other libraries, right? And those modules are kind of their own thing. They're their own little project that just happens to live inside of CPython. And I think the result of all of this conversation of like, oh, what do core developers want from Rust was like, hey, let's try something. Maybe having a standard library extension module written in Rust, and like, what would that take? What would that look like? Would we need to change the build system? Would we need to, what would actually need to happen for that to be a possibility? And I think there's some like huge benefits to having Rust. I mean, David talked about a whole bunch of them where it's like it's this new language. There's lots of new programmers that are interested in it. It has all the memory safety stuff. It has all the performance stuff.
The threading.
And also, yeah, free threading works really great with it. There's just like tons of benefits to having Rust be a part of like a Python developers toolkit. And it's like, how can we also have that in the core libraries? And I think the answer was like, try it out and see what happens, and maybe who knows, right? Like they definitely like core developers caveated it as like, it'll definitely have to be an optional part of the standard library because not everyone is going to be using Rust on CPython. And yeah, maybe not one of the core parts of the actual interpreter and the runtime, because they're quite well used and well maintained right now. So we'll see. I think it's going to be interesting to see if David and some other interested folks will put together something like a standard library module that uses Rust.
Yeah, maybe in 2035 we'll still be doing this. We'll still be talking about, but we'll be talking about how the C adaptive layer to integrate with Rust is working, so we can still keep all these C extensions running instead of the other way around.
Yeah.
A couple interesting takeaways. David points out, our best estimate is that somewhere between a quarter and a third of all native code being uploaded to PyPI for new projects is using Rust.
Yeah, so this uses like basically use this, it's py-code.org, where it can introspect into Python like packages, the actual files that are uploaded, and then looks for Rust. And so like any package that is using Rust and it's a new package or a new release, you can see like what percentage of new projects are using Rust versus like C or C++ or something else. So David was able to extract that data point. So yeah, there's a lot of Rust happening for new projects. Obviously, old projects are likely very C++ dominated, but what are new Python developers choosing to use?
Yeah, they didn't choose C. They just chose not to rewrite it in Rust yet, which is a different barrier, I suppose.
Yeah.
Not saying they should, but I agree that choosing new projects is an interesting metric. Mm-hmm. So a couple other things from here is like, should we rewrite CPython in Rust? There's a lot of people or a lot of comments of like, there's a lot of people who just don't want to learn Rust. They don't care about Rust. This is a challenge for CPython, is that the core developers in particular have a special skill of writing C and writing CPython in particular. Mm-hmm. And this moved the cheese for a lot of folks, and they like, how much do they care, right? Like they took Rust on Linux, Rust and Linux core as an example, right? People they don't want to change, which I'm not saying they should, but
yeah, it's a really difficult question, especially when there's like this really tight ownership of like one or a few people with like this very specific part of code, and they've been maintaining it for a really long time, and it's like it's hard to try to force that sort of change onto people. But then things that are new or things that are optional, like that's a really great place to start. I think learning from the Rust and Linux project is like a really great idea for Python because it's, in a lot of ways, even though Linux maybe is like an order of magnitude more complexity, I think that the situation or like the structure of the code in the project is pretty similar, where there's like this really big core and then there's like a ton of different smaller sub-projects that all have their own little owners, governance, contributors happening in the background.
Yeah, 100%. I mean, it is 2025. We could try again. Maybe we could just vibe code it like, hey, cursor, rewrite CPython in Rust, or you go to jail.
Is that the meta these
Please.
days?
That's there's this really great video. A senior engineer tries vibe coding, and it's always telling it like if it doesn't do it, it'll go to jail. But also says please, like, or you go to jail, please. It's amazing. I mean, as much as I joke, honestly, I do think AI code assistants could help in supporting the transition. I know it's good at C and it's good at Rust. Not that you should vibe code it. That's not what I'm saying. But anyway, we live in weird times, Seth. We do.
Yeah, we really do.
I think the other constraint here that maybe a lot of people don't track is that it's not just I need to somehow make CPython work on Linux, Windows, and Mac. And if we build it in Rust, that's a different tool chain. There are a bunch of edge cases and platforms that are not very commonly used that maybe Rust itself doesn't even support that Python has promised to keep running on, right?
Yeah. Or, I mean, even if not promised, right? Like there's people that are just running on these platforms. And then if something were to break, they would only show up when something breaks. And what do, right? Like you've been supporting these people for a very, very long time. And what happens then? What stability guarantees do you give those people that, maybe you're not like a tier 1 platform, but if you've been, making them use, like they've been using Python totally normally for all this time, what does that mean? So
yeah, well, we just talked about tier 3 iOS and Android support. Like, does it work there? I don't know. But you've got like this little MicroPython, CircuitPython chip that I got that's like, I don't know, like the size of a thumb or something. Mm-hmm. Does the build system work for that? I don't know. Yeah. But I'm running Python on it today.
Yeah, I think that like one of the things that got identified was the state of GCC support for Rust as like something interesting. So that's something to track if you're interested in Rust and CPython working together. That's definitely like a project that's outside of Python and Rust, like, and Maturin and Pyo3s if you want to watch that project.
Yeah. I did say we need to go faster. Lightning round to close things out here. I guess there's just the Pyodide. We didn't talk about the docs or the lightning talks. Like, what else should we say before we call it a wrap on this?
Let's go into the lightning talks and look at Guido's. I think that one was the most well received and interesting lightning talk, which is contrasting how Python is developed today versus how it was developed by Guido, and what sorts of things are we kind of like leaving behind by developing Python in this way, and is there anything that we can learn from how he
does he mean more committee, more community agreement, or what was he getting at?
I think it's the complexity side was the part that was really big for him, where it's like we're trying to, if you want to land a feature in CPython, you need to write a perfect PEP, come with a pull request that is, performant and secure, and the API is perfect, and it's been vetted, and it's been used, and like there's this super, super high bar to clear to add a feature to CPython. And you're not allowed to get it wrong the first go around, basically, I think was what he's mostly mentioning.
Because like demanding perfection means it's like the code equivalent of don't let good be the enemy, or the great be the enemy of the good, or something like that, right?
Sure. Yeah, exactly. Stuff like that, where it's like, hey, if Python were developed in that way early on, it wouldn't have worked out. Because it'd
still be in the lab or an idea or something.
Yeah. Exactly. So I think that's a really interesting one to check out if you're looking at the lightning talks.
Okay, cool. Now, I know some features have to be absolutely dead center in the core of the CPython runtime, like free threading. or a no-GIL initiative, or some new memory model, or whatever. But a lot of these things probably, certainly with the standard library, could maybe, you talked about the immutable, the thread-safe concurrency data structures. Maybe there's a more formalized path of starting these things as third-party libraries on PyPI. And once they reach a certain bar of maybe of adoption and maturity, then they make a step towards that. It would be interesting if, I know people can just go and create a project and do it, but like, here's the prescribed way of non-C runtime features being added to the language, and it starts out in public and it makes its way over.
Yeah, I think that got discussed in the last language summit too. I'm not sure if there's been any progress on like actually making a solid model for like, here's how you go from PyPI to PEP to standard library, but it's definitely, I think it's just going to keep coming up until that happens, because it's really common, right? Like, so many features get developed this way now.
And it's also, interestingly, some of the ideas of that direction have been rejected, like moving requests into CPython standard library was rejected because it would harm the growth and status of requests, not CPython. Even though request is clearly better than what's built into CPython for your access. Not throwing no shade, that stuff's been around for a long time, but
yeah, I mean, request is built on it, so it obviously does some job well.
yeah, exactly. It's just like a more user-friendly, higher level API in front of it. And we have HTTPX for like concurrent, basically async IO requests equivalent. So there's certainly history or examples of stuff starting out there, becoming very popular, but not wanting to go in. But specifically things that you might want to. Like, for example, would data classes be a thing if Pydantic was on a trajectory to sort of fill that role, or adders from Hennig or something like that, right? Maybe not. I don't know.
Yeah. No, I think that whole road of experimentation and then moving into the standard library, like, we're just going to keep seeing it, because it's such a great way to get stuff in the hands of users really, really quickly.
Yeah. And I don't think just like, if I just went out and made a library, said, I'm doing a library and I think it would be fun to have this as part of Python, like, people go, good for you, Michael. They would ignore it, right? But if it was a little bit blessed by the steering cat, like, we're experimenting and considering this idea as core developers. It starts here, but if it gains traction, it becomes Python, right? I think that is a different positioning than just like a random project that looks interesting.
Yeah, definitely. I think that last year, one of the things that got suggested was like, hey, maybe we allow people to have those sorts of projects once they reach some amount of maturity and like direction, to be housed under the Python GitHub org, to try to give them some sort of like legitimacy of like, yeah, this project is on the track to going here, and here's us showing that it is, right?
Yeah. I feel like I should just say one more thing though. I do think there's a lot of value in having Python be smaller and having a bigger ecosystem outside of it. I'm not suggesting that everything should just be moved into Python. I do think that just go like, I don't care what CPython does. If I like this HTTP library, I'm going to use it. And if it wants to implement itself in Rust or OCaml or whatever, I don't care. If that's better, they can go do that. And then I'll use it. And it'll be great, right? And that doesn't have to go through committees and all this kind of stuff. So I'm not necessarily saying like everything should try to like find a hub and spoke model into the core Python. But those things that do intend to be there, it would be cool to see like this sort of progressive path. People can get to it sooner. Anyway.
Yeah.
Final thoughts on that before we call it a show?
I think we nailed it, honestly.
No, we definitely did. We definitely did. Yeah, no, let's wrap it up. Thank you for doing this write-up. It's really interesting. I always value this look into, to where's Python going. It's a lot to take from it. Yeah. Final thoughts on this year's Language Summit?
It is a really exciting year to be a Python developer. I think that 3.14 it's got so many really interesting things and changes to try. I am quite excited to get my hands on the beta, but then also the stable releases. I really am excited to see what people actually then go and do with the stuff, right? Like building web apps with Python, building mobile apps with Python, building these massively parallel applications with Python. It's a pretty good time to be a Python developer
Yeah.
right now.
It's only getting better. Absolutely.
Yeah.
All right, Seth. Thanks for being back on the show, and thanks for doing the write-up.
Thanks for having me.
Yeah. See you later.
Bye.